Good morning. Our last lesson in our sequences and series unit is day 5, recursive and other sequences. So open up that document on your Inspire and let's get started. Go to page 1-2. I just remind you that so far we've learned about arithmetic and geometric sequences and series. There are a couple others that we need to be familiar with as well. Going to page 1-3. The first kind of sequence we'll talk about today is recursive, and so we're going to talk about the process of recursion. Recursion is the process of choosing a starting term, or you might call it initial term, and repeatedly applying the same process to each term to arrive at the next term or the following term. Sounds a little complicated. It's not. You're going to be given a first value and then a rule, and you're going to keep applying the rule over and over to get your sequence. So a recursive formula always has two parts, and that's how you'll be able to tell it apart from geometric or arithmetic sequences. The first part will always be the starting value of a sub 1, the first value of the sequence. And then you'll be given a recursion equation or formula or pattern for a sub n as a function of the term before it. So, for example, here I have a sub 1 is 4. That's the first term in my sequence. Then a sub n, each next term is 2 times the term before it, 2 times n minus 1, which is the term before. So my first term is 4, my second term will be 2 times the first term, 2 times 4 is 8. My third term will be 2 times the second term, 2 times 8 is 16, and so on. And we'll do some problems on paper next. Okay, so grab your paper, get ready to do some practice, and then we'll be done. Pretty short lesson today. So our first example tells you that a sub 1 is 5, and a sub n is a sub n minus 1 plus 2. I'm asking you for the first 5 terms of that sequence. So again, I make myself a picture and I label it. The first term is 5, easy enough to fill in. Now the second term, a sub 2, is going to be equal to a sub 2 minus 1, the first term before it, plus 2. 5 plus 2 is 7. A sub 3, the third term, is going to be equal to the term before it, a sub 2, plus 2. 7 plus 2 is 9. When you start to see the pattern, you can be done filling it in when it's straightforward like that. Are there other ways to define it? Sure. This is just recursion practice. Our last example is number 1-6. 1-6 tells you the first term of a recursive sequence is 3, gives you a formula for each subsequent term, and wants 5 terms again. So again, I make myself a picture to help keep organized. I know my first term is 3, I fill it in. And I start following the pattern. A sub 2, the second term, is a sub 2 minus 1, or 1, plus 2 times, and the number of the term I'm on is 2 minus 2. So the second term is equal to the first term, 3, plus 2 times 0. 3 plus 0 is 3. A sub 3, the third term of this recursive sequence, is equal to the term before it, a sub 2, plus 2 times the third term we're on, 3 minus 2. Second term was 3, plus 2 times 1, 3 plus 2 is 5. I'm not seeing a real pattern here, so I'm going to do some more substitution. A sub 4 is equal to the term before it, the third term, plus 2 times 4 minus 2. The third term is 5, plus 2 times 2, 5 plus 4 is 9. And finally, the fifth term of this recursive sequence uses the term before it, fourth term, plus 2 times 5 minus 2. Well, the term before it is 9, plus 2 times 3, 9 plus 6 is 17. And that's it. They're the first 5 terms of that recursive sequence. That's all you need to know for those. Let's do some more. When you go to page 2-1, you need to know that there are some sequences that are not arithmetic, geometric, or recursive. The most famous example follows. on page 2.2. We have the sequence 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and 144. Take a minute to think about how I get each term. Where does the 3 come from related to the others? Where does the 8 come from, the 13, and so on? Each term is determined by adding the 2 terms before it. And this sequence is called the Fibonacci sequence. And I don't know if I spell that right. You can look it up if you'd like. And that's it.